Hey guys, welcome back. I have Brantly Millegan with me, Director of Operations at Ethereum Name Service. Hey Brantly.
Hello.
Brantly will tell you more about the bounty that we just added today to the bounty pool at 0x Hack. And he will also teach you how to implement ENS into your project. So without further ado, the stage is yours, Brantly.
Great. Well, thank you very much. Great. Yeah, so I'm going to be talking about the Ethereum name service today. So my name is Brantly Millegan. I actually don't work for ENS. I mean, we often say that as a shorthand. I work for a nonprofit called True Names Limited, which is the de facto manager of the open source project ENS, Ethereum Name Service. There's our GitHub. Our website is ens.domains, and this was created by Nick Johnson. So I'm going to first talk about what is ENS, then I'm going to talk about how ENS works, and then I'm going to talk about how to integrate ENS. So ENS, through name service. So I'm going to first talk about how is it a name service? Like, what is a name service or a name system? So a naming service is a lookup system. A lot of people overly complicate this. With ENS and DNS, the domain name system of the internet, you provide a name and it provides you information back. That's all it does. It's not forwarding on information. It's not forwarding on a transaction or anything like that. You provide a name, it provides you with information. Your computer might then do something with that information. That is separate from the naming service. So why do we even have naming services? Well, so we have computer identifiers, which can be automatically generated. They can be numbers and letters. The software can easily, distinguish these things. But humans like to read and remember words of a particular language that have social context and things like this. So basically, identifiers that work well for computers don't necessarily work well for humans, and vice versa, right? So we can't just humans don't want to have to look at the automatically generated, computer identifiers, but computers would be really bad at assigning the proper word of a language. So let's say something like automatically. That requires like social context and maybe the person wants to choose. So this bridges the gap. So ENS has names, it has owners of names and records that can store any arbitrary information. So if you have a name, you can look up and retrieve its records and then do something with that name. So for example, ENS provides your wallet with the cryptocurrency address and the wallet sends the transactions. Let's say I'm sending Dogecoin to Brantly.eth. So I type in Brantly.eth into my wallet. The wallet looks up Brantly.eth on ENS on Ethereum, grabs the Dogecoin address, which is stored there, comes back to the wallet, and then it sends the Dogecoin transaction on the Dogecoin network with that information. So ENS is not like forwarding the transaction or something. So why is it the Ethereum name service? It's not because it's a naming service only for the Ethereum ecosystem. It's because it's a naming service built on Ethereum. The logic and records are stored on Ethereum, but it can store information relevant to anything. So ENS uses Ethereum to serve the internet, including and beyond the Ethereum ecosystem. Our goal is to make ENS and therefore Ethereum a basic piece of internet infrastructure used widely by people, whether they are part of the blockchain community or not. That is our goal. We don't want ENS just to be some like niche thing here, And it's doing this by complementing the DNS tech stack in parallel, expanding the capabilities of the existing DNS namespace, focusing on use cases not served by DNS, and in some cases not possible on DNS. So now I'm going to talk about how ENS works. So ENS has no servers. This confuses some people. They say, okay, how do I, where's, your API? How do we get permission to use ENS or something? ENS proper is just smart contracts on the Ethereum blockchain. That's it. We don't run anything. They self-run. If we all died, it would keep running. You just need access to the Ethereum blockchain. There are three main parts to ENS. So there is the registry. So the registry is a smart contract that holds the names, the owners of those names, and the resolvers, and also TTL, which we don't really use, but it's technically there. The resolvers are basically, here's where you can find the records for this name. So then we have resolvers, and these are separate from the registry. Resolvers, a resolver is a smart contract that stores and serves records. So this is key. We don't just have one smart contract that says here's the names, the owners, and the records. I mean, we technically could do that, but that would mean that if we ever wanted to upgrade, let's say, the record set or something, we have to upgrade the smart contract that has everything, right? This would be bad. And so no, we separate these things out, and then we can upgrade, the contracts, like our record set contracts, without having to touch the registry, which is like, who owns what, which is like super important, right? The third part are you have registrars. A registrar is a smart contract that creates and distributes names based on certain criteria, for example, payment. So you've probably seen .eth names. .eth itself is owned by a smart contract, a registrar smart contract, that basically says if you submit these transactions to this contract that meet certain criteria, then it will give you your desired name. So that whole process of registration can be automated with smart contracts. So resolutions, though, like lookups of records, right, or whether a name is available or something, do not cost anything because you're simply looking up information on the public Ethereum blockchain. And that, again, you just have to have access to an Ethereum full node. So this can be done locally, like an Ethereum node on your local machine, or with an Ethereum gateway service like Infura or Cloudflare or something. You just have to have access to the Ethereum blockchain. But lookups, you're just reading, so there's no like gas fee or something. So let's talk about ENS records. So remember, a resolver contract is a contract that stores your records and like maybe has certain record types and things like this. Because the registry contract, where stores the names and the owners, just points to where the records are, you can decide to have that point to your own custom resolver contract. So with your own custom record set, you can do that if you want. Our team, though, we manage a record set that we call the public resolver because it's one that we manage and that like basically everyone uses. It has all these standardized records that we've standardized to like EIPs and things like this. So let's talk about these standard records. So we have addresses. So you can store any cryptocurrency address, an Ethereum address, a Bitcoin address, a Dogecoin address, any arbitrary cryptocurrency address. There's a content record. So this supports IPFS hashes, swarm hashes, Skynet, SIA hashes, and also Tor.onion addresses. We then have text records, which allows for any kind of arbitrary information. So text records actually have two parts. You have a text record key and then text record data. So the key is something really short that you can have anything you want, but it just like identifies what the data is, and then you have the data. So you could be like, the key could be email, and then the data is your email address or something like this. All right, so if you want to see an example of records for yourself, you can go to our manager app, which is at app.ens.domains, and search for Brantly.xyz. That's a name that I have on ENS, and I have tons of records there set up so you can see what's possible. So let's talk about the namespace on ENS. So you've probably seen .eth names, and .eth is what's called a top-level domain, and it is native to ENS. So this does not exist on DNS; it's only on ENS. And you can have like Brantly.eth or wallet.eth or something. But we're also integrating the DNS namespace. What this means is that if a name exists on DNS, we are allowing that to be imported into ENS with the same owner. You have to like own it on DNS first, and then you prove ownership, and then you could also have the name on ENS. Right now, we have the top-level domains .xyz, .lux, .cred, .co, .art, and .club integrated in various ways. They work different ways. And the rest of the DNS name space will be available for importing very soon. In fact, that feature of the entire DNS namespace being available is already on the ROPS and testnet if you wanted to test it out, and will be on mainnet like pretty soon. So just some words about ENS versus DNS. DNS is very good at what it does, but ENS has some advantages. So simpler infrastructure, so you replace servers with smart contracts. ENS, of course, has zero downtime by definition because it's on the Ethereum blockchain, and Ethereum blockchain has zero downtime. It's decentralized and therefore censorship resistant. You have built-in cryptography and individual ownership or self-custody, which I think leads to better security. Of course, if you're in the Ethereum ecosystem, anything in the Ethereum ecosystem, you have programmability, things that be owned by smart contracts, you can fit into that ecosystem. And of course, interactivity or composability with other Ethereum smart contracts. This is very, very powerful. Okay, so how to integrate. So the goal here is that every time a user might otherwise see a cryptocurrency address or a content hash or some sort of computer identifier, okay, they should instead see an ENS name or be interacting with an ENS name in some way. That is the goal. These computer identifiers should be hidden away. So the first use case is cryptocurrency address forward resolution. Basically, let's say you want to send somebody, like I said, Dogecoin or Link or something like this. Well, you don't have to get their Dogecoin address or their Ethereum address or their Bitcoin address. They can have that already set up in their ENS name. All you do is you just type in their ENS name, and the wallet grabs the appropriate cryptocurrency address based on context, and sends the transaction. Super simple. The second use case is Ethereum address reverse resolution. So the forward resolution is you have a name and it points to data. Reverse resolution is the opposite. You already have some sort of data, in this case an Ethereum address, and that points back to a name. So let's say I log in with my Ethereum account into a dapp, let's say Uniswap, okay? When you do that, you're giving the dapp your Ethereum address, your public address. And that sort of serves as your identifier in the dapp. And often they will even show an abbreviated form of your Ethereum address as showing what you're logged in with. This, of course, is bad UI because, who wants to look at this? This is not easy to read. What that dapp can do is do reverse resolution lookup and check, okay, does it have a reverse record ENS name associated with it? If it does, then show that instead. You can still show maybe the Ethereum address below it or something like this, smaller font if people want to verify. But the name is much better. And there's a number of dapps that do this. Uniswap does, CryptoVoxels, OpenSea, Aavegotchi, a bunch. Usernames is another type of use case. Reverse resolution is a key part of that. You could also give all your users subdomains or something like this. There's a lot of interesting things you could do. Then of course, IPFS swarm toward onion addresses also, I mentioned Skynet SIA hashes we just recently added support for. So let's say I'm in MetaMask Mobile, or I'm in the Brave browser or Opera. There's a number of browsers that support IPFS websites with ENS names. You can look on our website, ens.domains, for a full list. So let's say I type in, your dapp.eth, and it just resolves it like a normal website, shows the IPFS website. If you don't have Brave or Opera or MetaMask in your browser, also makes it so your browser accepts ENS and IPFS websites. If you don't have any of these things, you can still access these websites. We have a DNS bridge to ENS and IPFS with eth.link. So let's say I want to go to Brantly.eth, but I don't have the appropriate browser, so I just add .link to it. So now it's Brantly.eth.link, and that resolves like a normal website in any browser for anybody. We actually created this bridge with Protocol Labs a couple of years ago. We recently passed management of that over to Cloudflare, manages that. If you want to see a list of IPFS and ENS websites, I recommend going to almonit.eth.link. And there's like tons and tons of websites that people have created. So another ENS use case, you can store just traditional DNS records if you want. This is not widely used, but there has been some experimentation with this. The .cred top-level domain from DNS is using ENS and IPFS to store DNS records. You can look to them. And then everything we haven't thought of. So because you can have a custom resolver contract, so you can have your own custom record types, or because you can have custom text record types in the normal public resolver, you can store any arbitrary information. So like if your project has identifier where it would make sense storing that in an ENS name for a better, a better user experience, then great, do it. There you go. That's the presentation. Here's some useful links and way to contact me if you would like. So that is my presentation. So I don't know if there's like a way to do questions or something.
Thanks a lot, Brantly. Yeah.
Doesn't look like there's any questions.
Yeah, we don't have any questions at the moment. Yeah, we can help answer any questions that people might have on our Discord.
Okay, great. Well, so are we done then?
Yep, we are. Thanks a lot, Brantly. Thank you for your time.
Great. Have a nice day.